All right, let's come up, pick one of the sides. They're both the same, so don't worry if you pick one side versus the other. Let's take a look at this equation. Okay, it is a parabola. It's raised to the second power. Yay? Yes. Okay, some things we might know about this. So put that into the parabola equation on your sheet. Does it open up or down?
Up.
How do you know? The A value is positive, so this opens up. Because this is a positive value, it opens up. Okay? All right. So if it does open upward, does that mean that the vertex, so I'm going to put this little picture here. If it opens upward, is the vertex a maximum value or a minimum value? Minimum value, and if it's a minimum value, what part do you look at? If it's a minimum value, which value do you look at up there? The x or the y component? The y component. Okay? So be careful on that. All right, so vertex. How do we find a vertex of these? Negative b over 2a, and that finds us the x component of the vertex. And so if we go negative b over 2a, that's going to give me negative 4 over 2 times 2, which is negative 4 over 4, which is negative 1. How do I find the y component of the vertex? Plug it into the original. So I'm going to take negative 1, plug it in here, so I get 2 times negative 1 squared plus 4 times negative 1 minus 1. If I have negative 1 in parentheses and I'm squaring it, it becomes positive 1. Okay? So negative 1 in parentheses squared becomes positive 1. Positive 1 times 2 is 2. And then 4 times negative 1 is negative 4 minus 1. So 2 minus 4 is negative 2. Negative 2 minus 1 is negative 3. Right? So negative 1, negative 3, we have a point. That's our vertex. So everyone feel good about this so far?
Yeah.
Anyone stuck? Yeah. All right, so we talked about 2 different methods in order to graph it. 2 different methods in order to graph it. There was one where you could plug in 2 values to the right and 2 values to the left of the vertex. Plug that in, you get a y component out. And then there was the 1357 way, or the 135 way, but this is going to have a 2 in front, so it's not 135, it's 2, 6, 10. Good. Okay, so let's do the xy way first, just so we can see this. And again, it's going to come down to you, are you going to pick the method that works best for you? Gosh, I hope so. 1, 2, 3. All right, so in the very middle, I'm going to put my vertex. Okay? So I'm going to go 1 value to the right of negative 1 to get to 0. If I plug 0 into this, I get negative 1. If I go 1 value to the left of negative 1, what do I get to? Negative 2. And negative 2 also has a value of what? Negative 1. And you know that because you have symmetry. Okay? And then one more value to the right here is 1. If I plug 1 in, I get 2 times 1 plus 4. That's 6. Minus 1 is 5. And if I plug a value this way, negative 3 also gives us the exact same value. Oh, but before we go further, what's my axis of symmetry? X equals negative 1. So my axis of symmetry is x equals negative 1. So that's the vertical line that I can fold the parabola over the vertex on top of. And that's going to give us that. So I can plug these values in. So let's do these values all in green. Okay, we'll keep the vertex blue. We'll do it in green. So I have 0, negative 1. And then I have negative 2, negative 1. And then I have 1, 5. And then I have negative 3, 5. And if I did this, I'm going to get my parabola. Yeah? Does it cross the x-axis? Yeah. Do we know exactly where it crosses the x-axis? Not right yet. It might factor. I don't know. I haven't tried to factor it. But it crosses right around these two regions. If we can't find the exact value, they're called irrational values, which is fine. It's part of the answer. Okay? Now, if I did my pattern graphing, remember it's the 1, 3, 5, but in this one, it's going to be 2, 6, and 10 because of this lead value. So that means I'm going to go right 1 up 2. Oh, look, it's going to be the same point. Left 1 up 2. And then I'm going to go from that point, right 1 more, and do what with it? Up 6. So I'm going to go right 1 and up 6. And I'm going to go left 1 from here, and I'm going to go up 6. 1, 2, 3, 4, 5, 6. And this was just a coincidence, but look at that. By our pattern graphing or by doing our table, we were able to come up with the exact same point. Now you do have a axis of symmetry, which you may get as a dotted line or whatever, and it's not always necessary to put it. It's just please be aware that it is there. Cool? There we go. Let's go to the domain and range. Okay. So, guys and girls, domain. Domain. The domain talks about the x-axis. So think about the domain as you are driving along the x-axis. Now this parabola is going to go up forever this way. It's going to go up forever this way. Still with me? It's going up forever this way, up forever this way. That's in the y direction. So if I am driving along the x-axis, along that red line, if I'm driving for domain, D driving, domain. Still with me? So I'm going along, and I'm either looking way, way up or way, way down. Like, let's say it's a clear road. I know it's hard to fathom, but let's just pretend. Or on the road itself. If I'm way, way out here, do you think I can look up and see the green graph that's growing forever that way?
Yeah.
Yes. If I'm continuing to drive and I get to like here, can I still look up and see the graph? And if I get to like here, I happen to see it touch the line. It's like, oh, sweet. If I get here, I'm looking down and seeing it. I'm looking down and seeing it. And then it's on our road. If I look up now, if I look up now, and I look up now, I can still see it. So domains, for the most part, when we're talking about a parabola, it's going to go from negative to positive infinity. It doesn't matter if it opens up or if it opens down. Remember, we're talking about parabolas that open up or down for this class. So our domain for these is almost always going to be negative to positive infinity. Okay? So, D, domain driving. You're going back and forth. You can look up or down and see the graph. R is like you are on an elevator. Okay? If you're on an elevator going up and down the y-axis, there's a spot where you will start seeing the graph when you're looking out the windows of the elevator. There's no windows in the elevator. Okay, let's pretend there are. If you're riding up and down on this elevator, when do you start seeing the graph? At -3. Do I include that point?
Yes.
Yeah, so that's a square bracket because I include it. If I ride that elevator forever upward, do I continue to see the graph? So what can you tell me about the other part? Positive infinity. I don't know why I have that. There we go. Brennan, you got a question?
Never mind.
Never mind. Okay. So, the last thing I want to talk about real quick on this particular problem, we do see that it does cross the x-axis. It does cross here and does cross here. I don't think this would factor. If I were to take -1 times 2, I'd get -2. That means I have one value that's positive, one value that's negative. The factors of 2 are 1 and 2. There's no way that I can have one positive, one negative value of 1 and 2 and add together to get 2 positive 4. Do you agree? So -2 plus 1, that's not going to work. 2 plus -1, that's not going to work. It's not going to get me to 4. We can't factor this. It's a prime thing. If it's prime, In this case, it means it's irrational, meaning it's crossing the x-axis at two different points. We can't tell exactly where it is because we haven't gotten to that portion yet. It might be this, it might have an answer of like 1 plus or minus square root of 7 all over 3. So I have 1 plus square root of 7 over 3 and 1 minus square root of 7 over 3, something like that. Okay? But what about the y-axis? The vertical. Does it cross there? The y-axis always is this. Zero, negative 1. 0, negative 1. Crosses the y-axis. It's just one extra point. All of our parabolas that open up, all of our parabolas that open down will indeed cross the y-axis. It's just another point that we could establish. It is our 0, c. Because we have our A, B, and C's. It's our 0, c where it crosses the y-axis. We doing okay? Feel good? Can I move on? All right, flip that page over. It's going to look the same on the other side. All right, we got another graph. Let's see. Let's talk about y equals negative x squared plus 2x minus 3. What's something that's pointed out to you up here right away? A is negative, so that means what's the parabola going to do? It's going to open down. Okay? My A value is negative. This is going to open down. Okay, if it opens down, my vertex is a maximum value or a minimum value? The maximum. And if we look at the maximum at what value? The y of the vertex. Good. All right, so that's what our problem is going to look like. It's going to open upside down. Our equation we have opens down. Why do we know? Our A value is negative. Let's find the vertex. The vertex, we're going to use negative b over 2a. And we'll plug it in to get something else here. So I'm going to get negative 2 over 2 times negative 1, which is negative 2 over negative 2, which is positive 1. Did I do that right? Yeah. Okay. So if I plug this positive 1 back in, here's where people get stuck. I have a negative 1 squared plus 2 times 1 minus 3. That 1 in parentheses is being squared. What happens with the negative outside of it? It changes, becomes what? No! It's not in parentheses. I'm not squaring the negative. This is the biggest error kids are going to make. You're going to miss 1 point and 2 points every problem if you don't understand that negative out front. If that negative is going to change, listen real quick. Some of you have earbuds in. That's not cool. If that negative is going to change, it would have changed already. Negative x squared would have changed it. What is being squared on this problem? 1. The negative is outside. So that negative has to come along with it. So I get 1 squared, which is 1, minus 1. So I get negative 1 plus 2 times 1 minus 3. Negative 1 plus 2 is 1. 1 minus 3 is negative 2. So I get a value at 1, negative 2. There's my vertex. Axis of symmetry. X equals 1. Good. That's a vertical line. We could draw it in there if we wanted. It could be a dotted line. It could be a solid line. Doesn't matter. Doesn't really, it's not part of the graph itself. It's just a portion of it that they say is somewhat important. Okay, so we have an axis of symmetry. Okay, we can do the t-table if we'd like, or we could pattern graph. Okay, I'll go both. Okay, so if I do my t-table, I get xy. And in the middle, I put my vertex, yes? All right, so I need a value to the right of 1, which is 2, and a value to the left of 1, which is 0. 0 plugged in is going to be easy. 0 is going to get me negative 3. If 0 gets me negative 3, what does 2 get me? Negative 3. All right? I need a value to the right of 2, which is 3. I need a value to the left of 0, which is negative 1. Okay, which one's easier to plug in? I don't know. Sometimes when you have more negatives than you know what to do with, it might goof you up. So I might take the 3 and plug it in. So I get negative 3 squared plus 2 times 3 minus 3. What is this right here going to get me an answer as? Negative 9. Good. Plus 6 minus 3. Negative 9 plus 6 is negative 3. Negative 3 minus 3 is negative 6. If that gets me negative 6, what does negative 1 give me? Negative 6. It's symmetric about it. Let's plot our points, see what happens. So I'll do these all in black. Okay, so I got 1 counted 2. That's going to stay in red. And then I have 2, negative 3, 0, negative 3. And then I have 3, negative 6. And negative 1, negative 6. Okay, my pattern graphed 1, 3, 5. What do you know about it? What do you know about it? What's my A value? Negative. So these have to be negative. All right? Right 1, down 1. Oh, that worked. Left 1, down 1. Oh, it's right there. From here, I'm going to go right 1, down 3. Still there. Left 1 from here, down 3. Look at that. Our values plot right on there. This parabola opens down. Is it going to cross my x-axis? No. No. Does that mean ones that open downward don't cross the x-axis?
No.
They do or don't? They can. I could have this whole thing shifted up here and it would have crossed the x-axis, but in this case it's not going to cross. So if we went to try and factor this, it's not going to factor, but the factors in this case are not irrational, they are called complex solutions. They don't cross the x-axis at all. If they don't cross the x-axis at all, they're called complex. Reese.
I'm sorry, I'm just really confused how you dotted it on the negative 6. How many points are you supposed to go down if you're on the negative 3?
Well, you want to have a total of 4 extra points. You want the vertex in 4 points.
Okay, because I was either going down by 5, or I was either going
Okay, well from here I would have went right 1 down 5, left 1 down 5. So I went right 1 down 1, left 1 down 1, right 1 from this new point down 3, left 1 from this new point down 3. I would have gone right 1 from here down 5, down 5. But a lot of times it's not going to fit when you pattern graph.
All right.
You're going to be able to get a couple of points, but it's not always going to fit on your graph.
So usually we would go up from 1 to 3.
Mm-hmm.
Okay, then. Thank you.
Okay. Let's see who's paying attention. Domain. It's like we're driving on the x-axis. If I look down at any point, am I going to see the graph? Yep, so it's going to go from negative infinity to positive infinity. Still with me? The range. I'm on an elevator. Okay? When do I start seeing the graph? At negative 2, square bracket. And it goes all the way to negative infinity. Why not positive infinity? Because it's going down. My y components are going towards infinity. Okay? Did I answer everything? Okay, so guys and girls, sometimes it might be a better tool for you to utilize the table to fill out. Agree? Sometimes the pattern graphing is going to work for you. The pattern graphing has a 1:3:5 ratio times whatever my A component is. So if A is negative, my 1/3/5s are going to be negative. If A is negative 5, you're going to take negative 5 and multiply times your 1/3/5, and that's what your growth is going to be. Okay, so that's how it stretches it and compresses it. If your A value is negative, or excuse me, if it's a fraction, what do you think you would do with that fraction? Multiply by 1/3/5. So my fraction was 5 over 6. I would multiply my 1/3/5 by 5 over 6. There's a little too much talking that's taking place back amongst the tree. Okay? So we made it through a front and a back. I think we're kind of hitting these. Let's get a second page on this. Tristan, if you need to sleep, you can go to the nurse. You two, Gage. Casey wasn't sleeping. He's just back there talking. He's talking to everybody back there. He's just a social butterfly. We still love him. Hang on. So this page looks identical to what you just had. Looks identical to what you had. So let's start defining a few more things. So some go-to things that we've talked about. Hey, here's a question. Where does this, where did this one up here cross the y-axis? 0, -3. Did it indeed do it there? Yep, it's right there. Okay, yeah?
So for the 1, 3, 5 thing, is it always
Is it always what?
Is it always going to be 2, 6?
No, you multiply by.
You multiply by whatever your a value is. Okay, so the a value if it's 1 is 1, 3, 5. The a value is -1 is -1, -3, -5. If it's 2, if it's 10, if it's 80, if it's 100, if you add 100x squared, it's gonna grow at a rate of 100, 300, 500, which means the table might be a better way to graph it than because 100, 300, 500. A lot of my graphs I'm going to give you won't match it up, right? Okay. So, quick stand, real quick. Quick stand. Yep. We got a little dance. All right. This has to do with my a value. A value. Still with me? If my a value is positive, does the parabola look like this or look like this? Okay. A equals 3, make your graph. A equals 10, make your graph. Oh, Andrew did it. Bring them closer together. A equals 100, real close together. A equals 3, widen it back out. A equals -6, downward skinny. A equals -2, downward skinny. Okay? A equals 10. A equals -6. There you go. Teaching you guys how to dance. Big dance coming up. You guys be like, dude, A's equal to 3. All right. Ready? So some guarantees that we're going to know. Guarantees we know. Parabolas open up and down. The a value dictates whether it opens up or down. The a value also dictates how it's stretched. Okay? With our 1, 3, 5 pattern. All of our parabolas that we're dealing with will indeed cross the y-axis at 0, c. That's my value that does not attach to a letter. The domain of all of our parabolas we're dealing with is going to go from negative to positive infinity. My range is going to deal with the y component of the vertex. The y component of the vertex. If it opens up, it's going to go from the y component of the vertex, square bracket, all the way to infinity. If it opens down, it's going to go from the y component of the vertex, square bracket, to negative infinity. Okay? If a parabola opens up, it could cross the x-axis. If it crossed the x-axis twice, and we can't see exactly where it's at because it doesn't factor, it means they are irrational numbers, meaning they are a number that we can't find the decimal equivalent or the fraction equivalent to. If it opens up or down and never crosses the x-axis for whatever reason, that means that they are no longer irrational. They are part of the complex numbers. Okay? That's where you're getting a square root of a negative underneath. So the picture could do a couple of things. So let's take a look at a graph that might look like this. I've changed the order. What's my a value up here? A is -1. Good. So a is equal to -1 up here. My b value, I don't have just an x term, so what's my b value have to be? 0. What is my c value up here? 9. Okay? If I go to find my vertex, that's negative b over 2a. Comma plug in. So I get negative 0 over 2 times negative 1. Well, that's 0. So plug 0 back in here, I get 0, 9. I get 0, 9 for vertex. Does this parabola open up or down? Down. How do you know? What's negative? A value. Even though it's out of order, the a value still is associated with x squared, right? So this is going to open downward. If this parabola opens downward, do you guys feel that it will cross the x-axis twice?
Yes.
Yes. Okay. Do we know exactly where it's going to cross at this point? Oh, I don't know. Hey, Ray, what kind of problem is that? 9 minus x squared? Yeah, it's the difference of 2 squares. This happens to be the difference of 2 squares. So this is going to break down to 3 plus x and 3 minus x if I factor it. Okay? If I wanted to know where these saw or cross the x-axis, I'm going to go 3 plus x is equal to 0, and 3 minus x equals 0. So x equals negative 3, and x is equal to positive 3. So I think. All right, so x is negative 3, x is positive 3. Hey, can I pattern graph this one? And if I pattern graph, what's the 1, 3, 5? If I pattern graph, what's the 1, 3, 5? Negative. Okay? So I go right 1, down 1, left 1, down 1. From here, I'm going to go right 2, down 3. And from here, I'm going to go left 1, down 3. And from here, I'm going to go right 1, down 5. Oh, sweet, it fell right there. This one goes left 1, down 5. And I could go right 1, down 7 if I wanted to keep going. Okay? Axis of symmetry on this one is? Our axis of symmetry is x equals 0, so it's this. Write down the y-axis. Hey, where does it cross the y-axis? Where does it cross? 0, 9. Domain? Negative, positive, infinity. My range, where am I starting? 9. Am I going up or down? Down. So it's going from 9 to negative infinity. Okay, could I plug this into a table? Sure. If you plug 1 in, 1 and negative 1 will get you the same answer. So you get 9 minus 1, which is 8. So 1, 8 and negative 1, 8. If I plug 2 in, I get 9 minus 4. If I plug negative 2 in, I get 9 minus 4. That's 5. So 2, 5 and negative 2, 5. Sweet. Table works. Okay? Does it cross the x-axis? Yes. Do we know exactly where it crossed the x-axis? Yes. How did we know where it crossed the x-axis? It factored. We set my two binomial factors equal to 0, and that will tell us where it crosses the x-axis. Show me with your hands. A is positive. Make your graph. A is negative. Make your graph. Okay? If A is 10, make your graph. Skinnier. If A is 2, a little bit wider than that. Cool? Gotcha. You guys are doing it. All right. Last problem I want to show you. It's going to look a smidge different, but I think you're going to handle it. I think you're going to be able to handle it just fine. Can I move off here? We don't like different. I like different. Different gives us a different kind of flavor sometimes. All right. Ready? Ready? Take a look up there. Does it look different? Is it factored down?
I don't like.
So if it's factored already, what can I do with the binomials to find where it crosses the x-axis? Equal them to 0. All right, so it's already factored. I'm going to take this, and I'm going to take this. I didn't take the -2. I didn't take the -2 and do anything with it, did I? All right. So what's x equal to? -3. What's x equal to?
2.
+2. Okay? I know that a parabola is symmetric about the axis of symmetry, which means it's symmetric about the vertex. So halfway in between those 2 points, we're going to find the x component of the vertex. Little critical thinking taking place. Okay? So let's do this. If I go to 1, and if I go to -2, can I still come in? I go to 0, and I go to -1. What's my halfway point? What's halfway between -3 and 2? What? -1/2. -1/2 is right in the middle. Okay? Can we have a vertex that has a negative or a fraction? Sure. If I take -1/2 and plug it into my x values here and here and work it out, I'm going to get my y value. Okay, so I got a little work. -2 times -1/2 plus 3, and -1/2 minus 2. So we have to do a little arithmetic. Your calculator can handle it. -1/2 plus 3 is 2.5, or 2 1/2. -1/2 minus 2 is -2 1/2, or -2.5. Negative times negative times negative, or negative times positive times negative means it's going to be a positive answer. 2.5 times 2.5, well, 25 times 25 is 625. So if I take 2.5 times 2.5, it gives me 6.25. And if I take 6.25 and I multiply it times 2, I wind up with 12.5. Okay, I'll do that one more time. 25 times 25 is 625. So 2.5 times 2.5 is going to have 2 decimal places moved in. So 625 with 2 decimal places moved in is 6.25. 6.25 times 2 is 12.5. You're going to have to trust me on this one. All right, so if I graph this, I got -1/2. -1/2 is in between. I'm going to go to 12.5. -1. Oh, wait. What? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12.5. Oh, it's supposed to cross there. Cross there. All right. Would pattern graphing work? Yes. If I went right 1 from my vertex, so if I went right 1 from -1/2, I get the +1/2. And I'm going to go down -2 because this is my growing factor now. That's what my parabola is going to look like. Domain, positive, negative, positive, infinity. Range, it's going to go from 12.5, square bracket, down to -infinity. Done. Okay? It's a little different. So can I do a real world application where you're just kind of chilling? So if I drop this pen to the ground, it's accelerating towards the earth, right? It's accelerating towards the floor. Still with me? Okay? So, distance equals 1/2 AT squared. Okay? Distance equals half times the acceleration times time squared. Okay? The acceleration of Earth is roughly -10 meters per second. It's easier if we use -10 meters per second than something else. Okay? So, if I was here on Earth and I said, hey, how far would I fall if we made this in seconds if I free fell for 3 seconds? 3 squared is 9 times negative 10. That's negative 90. What is half of negative 90? Negative 45. So if you were on top of a building that was tall enough and you decided to see how acceleration of gravity went, let's say they have a big trampoline below, after 3 seconds of free fall, you would have fallen 45 feet. How far is 45 feet? This ceiling is 9 feet tall. So taller than this building. It's about the tall of the arch on top of our swimming pool to the ground. You got a lot of time to think. Don't you? We used to go to the lake in Arizona, a place called Apache Lake. They had great cliffs to jump off. And we had one we called Two Screamer Hill. Because you could hear somebody go, ah! And then you'd hear them go, ah! And they'd scream twice on the way down before they hit the water. It was fun. You only made the mistake once of making sure you're hitting the water without having your feet together as a guy.
You know what? I had the same experience.
You had to start making rules of going, okay, so this time, he's passed out because he's in pain. Make sure your feet are together. That's like when we used to ride our bikes off the roof into the pool. You had to make sure your feet stayed on the pedal. And again, you discovered that by making up a rule. You watched your first friend, that was Steve Zabinski. The bicycle hit the water, his feet weren't on the pedals. The bicycle hit him in a place that he didn't want to be hit.
He doesn't have kids now.
So we, as your kid, okay, so from here on out, make sure this doesn't happen because your friend got maimed. Your friend got maimed somehow, so then you have to make up a rule. Yeah.
Yeah, I was gonna say I had the same experience at a pool party where I thought it was a great idea to do like the splits in midair before I came crashing down to the pool.
Normally, you discover real quickly that it's okay to.
Oh, it was a really good discovery.
It is. Yeah. There's all again. When you're a kid, you discover all kinds of things. It's discovery learning. Guarantee you and your friends go through a lunch buffet and the thing says caution hot. Y'all are gonna touch it. And you're like, dude, it really is hot. Wet paint, guaranteed you're going to touch it. Wet cement, yeah, we got to see if we can stick our finger in it. Then you get yelled at by the guy. So, guys and girls, one last scenario that takes place. There is a problem that is on somewhere on one of your pages. Shh. And it talks about a rancher. And a rancher has what's going on, sunshine? So there's some rancher problem that says, hey, we have this scenario. What does my vertex mean? And it basically means, you have a length and you have a width. That means that this here is some length that's going to give you your maximum and then your area. So your vertex can be labeled as x comma y. In this case, it could be labeled length comma area. So that would be a maximum area. So if I had a value that was right here, and let's say this value here yielded us an x value of 7 and an area of 100, that would mean that if I had 4 and 12 as my dimensions, that should yield us the area of 100. Now, it came out a little goofy because I just made this up arbitrary. But this would basically mean if my x value changes, then I get a changed area. This would be my maximum volume up here, or my max area. And that's what we got. So, homework tonight is going to consist of page 55, which is worksheet number 7A. Okay? And it's 55. 55 should be fine. You're just matching the graphs. Now, guys and girls, starting tomorrow, if you have the graphing calculator, I'm going to show you how to use the graphing calculator with these. If you don't have a graphing calculator, guess what you're going to have to do? Get one or graph it by hand. Okay, I've shown you how to graph it by hand. But you're going to be going, why are they all done with their quiz already? Because they have a graphing calculator. Why am I not done? Because you're graphing it by hand.
Oh.
Okay? So if you have the graphing calculator, if you need to take a picture of these pages, come take a picture of them. It's in the basket. If you want to take a picture of it. Guys and girls, I should be in my office most